Hello, welcome to On Wildlife. I'm your host, Lorrie Rea. On this podcast, we bring the wild to you. We take you on a journey into the life of a different animal every week, and I guarantee you're going to come out of here knowing more about your favorite animal than you did before. This week, we're talking about an animal that spends time both on land and in the sea. These marine mammals have evolved to thrive in their respective ecosystems, and there's a lot to love about them. To help me learn more about them, I have Dr. Lorrie Rea on the podcast, who is a research professor at the University of Alaska Fairbanks, and I'm so excited for you to hear my interview with her. So bring your snorkeling gear as we head out to the ocean to talk about sea lions. There are 6 different sea lion species, and our guest, Dr. Lorrie Rea, works specifically with Steller sea lions. Steller sea lions are also the largest species, weighing in at around 2,500 pounds and growing to be 11 feet long for males. The females are smaller than the males, but they can still weigh around 800 pounds. Sea lions can be found all along the western coast of North America, South America, and Australia. They can also be found off the coast of Russia, but you won't find them in the northern part of the Atlantic Ocean. Unfortunately, sea lions are endangered, and they're facing a lot of issues that we'll talk about later on in the episode. Now, Lorrie has a lot more information about them, so first, let's hear why she started working with sea lions.
My interest in working with marine mammals in general started back when I was an undergraduate student. I was volunteering at a facility that we had captive hooded seals at the university I went to in Canada. And so I started with cleaning out their tanks, but then over the next couple of years, kind of got included in feeding the seals and how to take blood samples, how to work with the blood to understand the health of the animals. And as a senior, I did an undergraduate research project measuring metabolic rates. So trying to figure out how much energy these guys used when resting in the water. And so that's pretty much what started my career. I continued doing that kind of research as a master's student on elephant seals in California, trying to figure out how they conserve their energy during fasting, because they go through this crazy, 9-week fast after only being nursed for a month. And then I started working on sea lions when I started my PhD, trying to understand if sea lions were fasting or fasting beyond their limits in some areas that had population decline. And I've been working on sea lions and other seals ever since.
It sounds like Lorrie is doing some really interesting research. I asked her to talk a little bit more about what she's doing with sea lions.
Yeah, so my work with sea lions, as I said, actually started out because I knew something about fasting. They were having a big population decline in part of Alaska, and we wanted to try to figure out if the pups were starving. And so I was basically coming in to look at their blood chemistry to see if there was indications that they were fasting longer than they normally would when their mom goes away to sea to feed. And so that continued on. I started doing more research in fasting, worked at a captive facility where they had sea lions in human care. And so we did some studies there. Also, we've been looking at how much fat young sea lions have at different ages to see whether they're in good body condition and if they're in bad body condition in this area where populations were going down. And we've also been using natural chemical markers in their food, in fish and in squid and an octopus, to try to trace what kind of fish adult Steller sea lion females like to eat when they're nursing their pups. So what kind of fish is important to conserve and protect in these areas and at the time when these females are trying to raise their pups. And then more recently, we figured out that in this one area where population is not doing very well, we're finding these high levels of mercury. So over the last 10 years, a lot of my research has been focused on how much mercury is in sea lions. What does it do to them? How does it change their immune system? And also, where are they getting it? So we've been measuring fish, we've been measuring invertebrates. So when you kind of follow the story and what the questions are leading you, you kind of can really diversify. I never thought I'd be doing this when I was first, measuring metabolic rate.
Learning about their diet can be really important to their conservation. And we're even told not to eat too much tuna because it has a lot of mercury in it. So I'm sure it's even worse for sea lions.
Exactly. And that's actually one of the things that makes sea lions and other marine mammals, we call them sentinels of the marine environment. So they basically are large-bodied, they're long-lived, and they basically live in the ocean environment that we're interested in, and they eat exclusively fish and cephalopods, these octopus and squid. And so, you've talked about in some of your other episodes bioaccumulation of this mercury. And so we see this in the sea lions. And so they bioaccumulate mercury much faster than we would because we have a much more varied diet. And so they're good indicators to us that we see immediately there's something going on. There is mercury moving in some of these food webs or in high concentrations in some of these food webs. And so that's how they kind of are our first indicators or these sentinels of ocean health.
And mercury can cause all kinds of neurological issues and can stunt brain development. We'll talk about some more issues that sea lions are facing later on, but first, you might be wondering what's the difference between a seal and a sea lion?
So sea lions are a part of a group called eared seals. So northern fur seals are in with them as well, and other sea lion species. And so because they have these external pinnae, external ears, and they basically, the other difference from seals is that they use their front flippers, their large muscular front flippers, to basically raise their torso up off the ground. They push their hind flippers forward and they kind of walk on the beach, but it also enables them to climb rocks, even climb cliffs. I've been in a situation where we're walking on a beach with sea lions above us, which makes you kind of nervous. So seals, on the other hand, are often called true seals or earless seals. And so they have absolutely no external ear. They basically just have a little hole under the hair. And so that's kind of a morphology defining, but they also move very differently. When they're on land, they kind of lie on their side and hop, or they lie on their bellies and kind of pull themselves forward with their front flippers instead of walking. Sometimes they kind of get this undulating kind of inchworm kind of action going on as well. And they move different in the water too. So sea lions often will use their big, strong foreflippers to move in the water, and they kind of soar or fly in the water. Whereas seals mostly use their back flippers. They kind of undulate side to side to propel themselves through the water.
Wow, so there's a lot of differences that you can see. I never knew sea lions could climb up cliffs either. Now, sea lions are predators of aquatic animals, so they need to be able to figure out where their prey is and use different strategies to catch it.
Basically, they not only have to be able to hold their breath to get to the prey, but they also have to be able to find it. And so they basically have really good eyesight in dim light conditions. They got big eyes, which makes them so attractive to us on shore as well. But they also have a really dense and long whiskers that we also call vibrissae. And they're very sensitive to ocean current movements. And so they can sense very small movements, and so they find their fish that way. They also have a really high breath hold capacity. They can hold their breath to be able to get down to the depth and then stay there to do a chase if they need to. So lots of different things kind of contributing to them being really good hunters in the ocean.
It's really amazing what they're able to do. Because they have to be in the water for extended periods of time, I wondered how long they can hold their breath for.
Up to about probably 13 minutes, although if they are forced to, they could probably do more. But the average dive doesn't really take that much. With a young animal, 1 or 2 years old, their average dive duration, how long they hold their breath underwater, is only a minute or two. But for the longer dives, they can get up to about 13 minutes.
That's still a really long time, especially when you think about us. The average human can only hold their breath for 30 to 90 seconds. Sea lions also have some other adaptations that help them thrive in their environment, which we'll hear about right after the break. The The science word that I'm going to tell you about today is prokaryote. A prokaryote is an organism whose cells don't have a nucleus or other membrane-bound organelles like mitochondria or chloroplasts. We are eukaryotes because our cells do have those things. But just because they don't have a nucleus doesn't mean they don't have DNA. Bacteria are prokaryotes. Let's hear about some more sea lion adaptations.
They also have a lot of other adaptations that help them stay underwater a long time to be able to pursue and catch prey. And so one of them is they carry a lot of oxygen on board. And so they have molecules both in their blood and in their muscles that actually attract and hold oxygen really well. In the blood, it's called hemoglobin. And in the muscles, it's called myoglobin. So it's a chemical that basically, if you think about them as compared to scuba divers, they're kind of taking their own scuba tank, integrated throughout all their body tissues down with them, and they use it gradually. And then if they run out of air, we're goners. They can actually last a little bit of time using anaerobic respiration to be able to do long dives past that aerobic dive limit. So that's one of their adaptations. And then they're in a marine environment that's really cold most of the time. And so when I'm diving in Alaska, I always wear a dry suit. They use blubber. So I use air as insulation. They use blubber. And so they have a large fat layer right under the skin over most of their body, with the exclusion of their flippers. And so when they're on land in warm temperatures, they can actually use those flippers to get rid of heat if they have to.
Sea lions just keep getting more awesome. And with a lot of marine mammals especially, you see that they're great at regulating their body temperature because that's so important to their survival. Sea lions are also pretty intelligent too.
They're definitely intelligent. They're also curious. They always are exploring their environments. So the best example I can think of is these adult female stellar sea lions give birth to their young pups on these rocky islands in the middle of the ocean. They rely upon, they're separated. The pups need to stay on shore, but the moms have to go to sea to feed. And so, every day or day and a half, mom takes off to the ocean, is competing with hundreds of other females, other sea lion moms who are also trying to compete for those food, have to go out, find the grocery store, basically pick up the most nutritious prey they can get, find their way back to that island, and then find their pup in the middle of the hundreds of other pups, and to reunite and be able to basically deliver the milk that's going to nourish that pup. And they do that every day. And the pups move around a little bit. And we also see that there's actually a difference in how safe some of those spots on the rookery are. There's lots of dangers for young pups. They can get trampled by big males moving around. If they get too close to another female and that female is cranky, it can bite at them. And so we find that the older moms that have had a couple of pups already kind of tend to pick the same safer spots. And so there's a learning environment. And so it's all great evidence of intelligence. And as I said, they're really curious. They play with divers underwater. They kind of learn our patterns behavior. And even young pups will kind of explore their environment on shore when they're days to weeks old, using their mouth to, explore crabs on the beach or rocks. So lots of evidence.
So they have to be extremely keen to their surroundings and learn from their past mistakes. That, along with their curiosity, gives an indication of just how smart they are. Next, I wanted to hear more about some of the issues that they're facing.
One of the biggest things for stellar sea lions is they actually went through a really big, about 80% of their population disappeared over a 20-year period back in the 1970s and 80s. And so big population decline, particularly in the western part of Alaska, the Aleutian Islands and into the Gulf of Alaska. And so it's still really unknown as to what the main causes were. It was probably lots of different causes altogether. But what we've been studying more is why some parts of that population have continued to decline while others have kind of turned around and started to recover. So a lot of fishing regulations and kind of just new ideas about how to conserve wildlife were put into play in the early 1990s, and some of those have helped. But we still certainly face one of the biggest threats that we think of, and why we're focusing so much on it, is this high concentrations of mercury that we're seeing in stellar sea lion pups in the Western Aleutian Islands. These very remote islands in the southern Bering Sea, North Pacific, that look to be very pristine, away from all industry, but we're seeing that a high proportion of stellar sea lion females get mercury in their diet and pass it along to their developing fetuses. And to the concentrations that would cause harm in seals and sea lions. And so that's one of our greatest concerns. And so we're spending a lot of time trying to understand how mercury is moving through the food web. And in one of the locations that we've gone back to year after year, over 7 years, within 1 decade, we've seen a huge increase in the concentration. So this isn't an old problem, it's still getting worse. That's why we're putting so much focus there. But there's other things that challenge the conservation of sea lions too. They feed on fish. And when they see commercial fishing operations going out there that are kind of channeling fish, they also try to take advantage of that. And so for years, there continues to be some fisheries interactions, even though the fisheries have put a lot of effort into trying to develop new nets that exclude fisheries. They have tried to avoid areas, very close to breeding rookeries during the breeding period to kind of help decrease those interactions. And so that's what's happening in the area that I work in the most, out in the Western Aleutian Islands. But when you have sea lions occurring in places that are closer to higher populations of people, you get different interactions. So we see in populations in Southeast Alaska where they actually are pretty stable or even increasing, but they have a lot of interactions with both commercial and recreational fishermen. Again, sea lions try to compete for fish that are already on the line, and they get caught up in fishing lures and flashers. And they also, when there's more people around, we tend to have more marine debris or plastics. And so they can also become entangled in nets and become entangled in, say, plastic packing bands. And we actually have groups in Alaska that go out and purposely focus on disentangling animals that have had those kind of interactions, either remove lures or cut off packing bands. And there's lots of programs that are bringing awareness to the problem and also raising money for marine debris cleanup. And so things are definitely encouraging.
Lorrie just laid out a lot of problems that need solving if we want to save these sea lion populations. But it's good to hear that people are working to move this in the right direction. What else are people doing to help sea lions?
It's all great to be able to put teams together, very experienced teams together, to get out there and solve the problem after it's happened. But the most important thing is to do these preventative actions to try to keep it from happening in the first place. So there's lots of great work that's being done. A friend of mine about a decade ago started a program of education called Lose the Loop, trying to just educate the public about, please don't throw away any plastics that have a complete circle. Not only sea lions, but other wildlife get that stuck on them. And so whether it's packing bands from big bait boxes, just snip it instead of just taking it off whole, or even those plastic, things that hold your pop cans together, before you throw it away, just do the little snip, 6 snips, and you're safe for wildlife. There's also other programs developing noise deterrents that are safe and effective to try to just startle sea lions and other marine mammals away from fishing operations. And so that kind of work is underway. And from the mercury side, one of the biggest things we can do, and we hear it all the time for lots of different conservation measures, but try to consume less fossil fuels. When we burn fossil fuels for creating energy or coal or in the car, basically combustion of those fossil fuels has a mercury as one of the byproducts. And so the less new mercury we put in the environment, the better we'll be. Mercury is very stable and it stays in the environment for a long time. So if we can do anything to stop creating new sources, we'll be in good shape.
Those are all really great ideas, and it's not only helping the wildlife, but helping us because we eat seafood too. So how can the average person help sea lions?
Well, there's lots of great school programs like marine stewardship or marine guardian programs. And a lot of these are focused on how do we basically use renewable energy better, or how do we reuse things better? How do we reduce the amount of plastics better? And so I've just been really impressed with some of the innovative things that some of our school programs have been coming up with. We have a few here in Alaska who are very active. I know there's some down in Washington State that I've seen the results from. And it's just so incredibly, basically working with kids to get them excited about their marine environment and the terrestrial environment they're interacting with every day, is some of the best ways to spread the news to their families and have great results for the future.
I absolutely believe education is the key to changing our planet for the better. I want to thank Lorrie for coming onto the podcast and giving some amazing insights into the lives of sea lions. After learning about some of their cool adaptations and their intelligence, who wouldn't want to help out these amazing creatures? It could be as simple as cutting the loops out of products with plastic in them, or cutting down on your plastic consumption altogether. If you want to help out sea lions, you should check out the University of Alaska Fairbanks' Marine Ecotoxicology and Trophic Assessment Laboratory. You can also take a look at the National Marine Mammal Foundation and Pacific Marine Mammal Center. Thank you so much for coming on this adventure with me as we explored the world of sea lions. You can find the sources that we use for this podcast and links to organizations that we reference at onwildlife.org. You can also email us with any questions at onwildlife.podcast@gmail.com. And you can follow us on Instagram at on_wildlife or on TikTok at onwildlife. Don't forget to tune in next Wednesday for another awesome episode. And that's On Wildlife.
You've been listening to On Wildlife with Alex Rea. On Wildlife provides general educational information on various topics as a public service, which should not be construed as professional, financial, real estate, tax, or legal advice. These are our personal opinions only. Please refer to our full disclaimer policy on our website for full details.